about like random stuff too.
They never make sense. People trying to make connections, you know? People trying to find other people.
Pen pal.
Build relationships. Pen pals, yeah. Pen pals are so good. Okay, so two different methods of solving these quadratics. The first one is by square rooting, and the second one's by factoring. So both of these directions mean find x-intercepts. So picture a U-shaped graph and find where they cross the x-axis. But there's more than one way to solve a quadratic equation. There's four that you have to learn in Algebra 2. There's four ways to solve a quadratic equation. And you already know square rooting, and you already know factoring. And we're going to do a third way. We're going to begin it today and really learn it tomorrow.
The square root property or completing the square.
Completing the square. It's the third way we'll learn. So solve by square rooting means you're going to work to isolate the x squared. So you're going to get x alone. And the only reason you're able to do this with the way this is set up is because there's not an x like in the middle. If there was an x in the middle, you couldn't just move things in square root. It wouldn't work out. So you can kind of see how 1 and 2 are set up differently than 3 and 4. And so when there's, depending on how a quadratic equation presents, how it's set up, that's what helps to determine how you solve it. So I'm going to cancel the 108 through subtraction. I get 6x squared equals negative 108. And then I'm still trying to get x alone, so I'll divide by 6 on both sides. $18. So we get x squared equals negative 18. And now trying to get x alone, again, it has a power of 2. To cancel out an exponent of 2, use square root. The opposite of squaring is square rooting. Square root both sides. The square root of x squared is x. And here I'm going to write plus or minus the square root of negative 18. Yeah, so we got to go further with this radical. It's just kind of, showing that this is the process of solving. This equation has been solved. However, our radical is not in simplest radical form. So we practice simplifying radicals for this very purpose so that we can simplify our answer completely. So you're going to keep going. I'm going to do 9 times 2 here. You didn't divide 6 first. You got to divide that 6 on both sides before you square it up. If it was 108 without that 6 in front, I would have done that. So just divide 6 on both sides. Alright, and the square root of negative 9 is 3i. So our final answer, x is alone. We got our plus or minus sign. 3i square root 2 is simplest radical form. So, Jackson, was your 6 stuck under your radical? Did you have a 6 right here? You just kind of ignored it. Okay. Who's got a good question? Beginning to end. Alright, number 2. Same steps, number 2. Getting x alone. Put your line in. You have a plus 4. You don't want it there, subtract it. Isolate x squared. Okay, trying to get x squared above. Divide both sides by 4. X squared equals -1. Alright, we need to do the inverse of squaring, and the inverse of squaring is square rooting. I'll square root the left and right side. So the square root of x squared is just x equals, I gotta get my plus or minus in there. Whenever you solve by square rooting, you think of the positive or negative possibility. And the square root of -1 is I.
So you don't have to do the square root of 1.
You could, but it's kind of like showing too much.
So would it be like
Well, I could have gone like x equals plus or minus the square root of -1 like that. And the square root of -1 is I by itself. Did you put a 1 on the outside? That's it. What absences today?
Okay, Addison had one.
Yeah, no, everyone's been absent. They're either excused or. It doesn't factor.
You can't, it's fine.
Yeah, fine.
So it's just not able to do that.
Yeah.
whatever.
And I sat there thinking about it.
No, I thought, well, I'm sorry.
All right, so let's move on from square rooting to factoring now. We have not factored in a while. So I'm gonna actually pass out your quizzes today from when we did factor. It's been a long time, so you can do corrections and just kind of remember, oh yeah, that's what factoring was. Yeah, it's already been in focus for like, it's been out there for over a week. So your other quizzes, they're not in focus yet. All right, so we need to find numbers that will multiply to 21 and add to -10. Mhm. Factoring. All right, so 7 times 3 is 21, and 7 plus 3 is 10. Now we need a -10, so let's just make both of those negative. So our factored form would be x minus 7, x minus 3. We still have that equal 0. If you're asked to solve, you do the little mini equations and you solve both of them.
What if you just get asked to factor in?
Then just stop with the parentheses.
But then what if the question asks you to just put it in the simplest form? Do you solve or do you factor?
So simplest form is standard form, how the problem started.
Oh.
Mhm.
Well, no.
Yeah, good question. You're asking me if this is a review? Yeah. Yep. So we've already, number 3, solve by factoring, done. You've had a quiz on it. You know how to do it, right? No. This was before that open up. No, this was the open note one. This was open note. Yeah, because you had to graph and factor, and I let you use your notes to graph.
Oh, wait, no. They
Yeah. Yeah. Oh, so what I'm passing back to you today is not on factoring. It was on solving a system where you graph two lines and you find where the point intersects. That's what no, I am not passing back the open note. You'll remember when you see it. Okay. So solve by factoring. What multiplies to -4 and adds to 8? I'm gonna make sure that I'm trying everything. Okay, not possible. All right, this is not possible. It cannot be factored. You can call it prime, and then you cannot be factored. However, it can be solved. It can be solved.
Let me guess. By completing the square.
Yeah.
Good question.
That's what we're learning today.
Yeah. When the quadratic cannot be factored, use another method. Okay, there's two other methods. If a quadratic equation can't be factored, there's two other methods that you're going to learn that can solve anything. You're going to do either completing the square, which we're going to work on this week. It's got a lot of steps, kind of complicated. The reason it's kind of complicated is because it's useful when things can be factored. Or you're going to do the quadratic formula. The quadratic formula is less complicated, but actually leads to a lot of errors. A lot of people mess up when they do it. So completing the square will actually go over today and tomorrow and the next day. I'm going to show you how to solve this completing the square, but you don't need to do it. You don't need to write it down. I'll just give you a heads up about what it's going to look like. So today I'm going to teach you just the first steps of how to do this. All right, so we got a troublesome equation here. Can't be factored. Since it can't be factored, what we're going to do is we're going to rearrange it and make it something that can be factored. So we're going to rewrite it so that we can factor it. I'm going to move C as my first step. So I'm going to get this number out of here. I couldn't find numbers that multiply to this and add to this, so I'm going to move it to the other side. So I'm going to leave a blank space in here for a better number, a number that does work. Leave a blank space. The number that works, I mean, it has to be a very specific number, right? It has to be rewritten. The number that works, there's actually a formula for it. You take this number in the middle, called b, you put it over 2, and you square it. So 8 divided by 2 squared is 4 squared is 16. So I'm going to make this problem have a 16 in it. With algebra, whatever you do to the left side, you do to the right side. So I'm going to put a 16, which is going to work better for my problem, on both sides. Now I'll rewrite it. My new equation is x squared plus 8x plus 16 equals 20. Now I'm going to ignore the 20, and this is something I've created, and the way I've created it means that it can be factored. So I'm going to factor this side. What multiplies to 16 and adds to 8 will be 4 and 4. And it's going to work out like that every time. The way I created this number means that this is a perfect square trinomial, and the factors will be 4 and 4.
From there, do you just do the mini equations on this time equal to 20?
No, you can't do that. That's a good idea. I thought about it for a second. All right, so I'm going to write this as a binomial squared. X plus 4 squared is 20. Then I'm going to solve by square rooting. So this method combines factoring and square rooting. So now I will square root both sides to get rid of the exponent. And I have x plus 4 equals plus or minus square root of 20. And then I have one step to get x alone. I'll subtract 4 from both sides. Negative 4 plus or minus the square root of 20 will be the answer.
So you don't like, oh.
You do.
Well.
So this is called completing the square. So today we're only going to be doing, like I'm not going to ask you to recreate anything. We're just going to do like 2 steps of it. Tomorrow we'll do 2 more, and then you'll put it all together. But it's really cool in that it solves problems that can't be factored, which is like a really big issue.
Do you ever combine 2 terms? Like, would you ever combine -4 and 2?
No. Because this is not 2. This is 2 times the square root of 5, which is something else altogether. It's got to be like maybe 6. Like the square root of 5 is like 2 point something. So this is actually like 4 point something, not 2. You know what I mean? Like there's a whole multiplication in it. Okay, so anyway, you didn't have to learn that just then. You have plenty of time to figure it out. Let's go over homework from Friday.
I don't understand my mind anymore.
I did some of them in class, I believe. Most of them in class? Why? What's this been broken up for me? Alright, it was 19 through
41.
41 on. What? Wow, I've never done that. Oh my gosh, that's a really neat update. That was not available last year. I'd like to stop it now. What's this one do? Started playing.
What is the
1 plus pi, apparently.
Yeah, I didn't simplify that.
Yeah. The square root of 1. The square root of 1 is 1. The square root of -1 isn't really supposed to be the same because -1 is squared and +1. If that addition, then you shouldn't get a negative.
I have no idea. I can't tell.
Which one?
35.
No, if it's real, then that's the best we can do.
1 over 3 minus 5 over 3. So just like -5 plus 4 over 3. Or plus 5.
Yeah, there was questions on Friday, so like, hey, we can spend more time on it. Boy, it's so boring. I like tested this like literally 15 minutes ago. So should I do 31? Or could you not read it?
It's 35 that I'm confused with.
Okay, I'll do 35 and then I can do 31 too. So we're gonna do the conjugate. If you didn't put it in order, go ahead and put it in order. But if you have everything right, I don't know. I take points off. I take points off if it's not simplified.
I see what I did wrong there too. She like divided by 3.
Oh, this is yeah, divided by yeah. 59 minus 3 times negative 9 times negative 1. So I would do 3. So I would do 3 minus 15i over 9. And that actually does need to be simplified for full credit. You can have it in the other order, but since all 3 divide by 3, you need to divide them. You can take your vote out. So when I divide everything by 3, I get 1 minus 5 over 3. Or you could split the fraction. No, that one's positive. Other questions? Alright, are you good on 31?
Nope.
So 15 minus 9i plus 25i minus 15i squared.
Oh.
Okay, when you're feeling good about your answers, get out the note handout I gave you Friday. If there's a mistake, I have to take it. So this answer was right. You tried to simplify it.
What?
So what it would be the equivalent amount as if you went to Alright, I believe we skipped skill 3 in class, so go ahead and do skill 3 right now. Does anybody else absent Friday? You know what I don't want to do skill 3. We're gonna run out of time if we do that, so let's jump right into the back here. 4-5 completing the square. So starting chapter 4, section 5. Doing what I just showed you in Bauer, a little bit at a time. Yeah, 4 or 5. It says skill 6. Solve perfect square trinomials by square rooting. Factor the perfect square side. Square root, leave answer in simplest radical form. Alright, so these problems, this is set up for you. Go ahead and do what the bullet points say. Go ahead and factor this highlighted part. What multiplies to 25 and adds to negative 10? It would be x minus 5 times x minus 5. Okay? This is called a perfect square trinomial. So when you factor it, you can just square root. The square root of 25 is 5. Square root of 25 is 5. Those are the numbers. And they're both minus because of that minus sign there. Alright, so I showed you this a moment ago. If you have the same binomial, you can rewrite it as a binomial square. Just instead of having it twice, write it once, put a little exponent on the outside. And now you're gonna start solving it. So square root both sides. Square root sign, square root sign. That this square root sign clears the exponent and the parentheses. X minus 5 is plus or minus the square root of 27. Maybe make yourself a little note. You know, don't forget the plus or minus sign. Nope. Nope. So now we have to, we're trying to figure out what x is. So I'll add 5 to both sides. It'll go in front of the plus or minus sign. And the reason we spent days simplifying radicals is so that we could write this answer correctly. So we want to put this in simplest radical form. 27 is 9 times 3. Square root the 9, put a 3 on the outside. 5 plus or minus 3 square root 3 is your answer. You cannot add 5 and 3 and make it 8. This is not 3 here. This is something much bigger than 3. Okay? Alright, you guys want to try the second one? Go ahead. I'm going to be doing it up here, but you go ahead. Oh no, is this my same problem? No, I don't know. I still have my problems. Try it though. Sort of looking like that. Like that. Alright, we'll square root the left and the right. X plus 4 equals plus or minus the square root of 20. Subtract 4. X is negative 4 plus or minus the square root of 20. 20 is 4 times 5. The square root of 4 is 2. X is negative 4 plus or minus 2 square root of 5.
It's not terrible.
It's not. Yeah, it's not terrible. So I'm going to do one more thing to practice. Skill 7. Create a perfect square trinomial. Given A and B be to make something that could factor easily. So if you have the power to make C anything you want it to be, make C something that factors easily. And the way you make C something that will factor is to put B over 2 and square it. So we're finding the value of C that creates something that will factor. Jackson? Yeah. 64. So I want this trinomial here. 64 is the best number to put in the C spot. What's the best number to put in the C spot in 13, Alexis? Can you tell me what B is in 13? I'm going to put negative 14 over 2, and I'm going to square it. That's negative 7 squared. That's 49. The best number I could ever hope and wish for in this problem would be a 49. That'd be my favorite number in that problem. All right, so in your assignment, you have to do problems like solving by square rooting, what we just did, and you have to create C values. So you guys can open that up and start it, and I'm going to pass back your quizzes.
There you go.
Correct on my pen and then put it in the basket in the front. Don't make corrections in pencil, I won't be able to see it unless you do it on a separate paper. In pencil?
No, like what do we do with the correction?
What?
Do we get points?
You lose points if you don't do corrections. Required. Required. Then you look at your mistakes and try to figure it out.
You want us to solve or just factor? Solve this equation using the square root property.
Yeah, so. You gotta use that paper you just did at the homework.
You're fine.
This is from a long time ago.
No, I'm on the paper.
Yeah, you were here Friday. Look in your folder.
I got some stuff. I only bring my math books. That's about it.
Well, you know, at least you're bringing your basketball.
Yeah, that's the only thing I'm bringing.
It's something. You can get
That is
better.
fine.
You can get better.
Because none of my other classes have.
Yeah. Go ahead, do corrections on numbers 1, 2, 3, and 4. I was looking for the vocabulary that we discussed for these systems. So if you just put no solution, I give you half credit. I was looking for inconsistent. Oh, sure.
The same line.
They aren't the same line, they're two different lines. Did everybody get one back? Hey, Jared, did I give you one back, please? Emily, are you going to do fraction? 1 through 4? Any questions on 1 through 4? Any questions?
I got that question right. Ooh. I got it.
Let me know. If you want to, this ball might clearly did this and this, or I had a certain point, you let me know. Alright, I'm going to scroll. Yeah, definitely on any of these 4 problems, which have several steps, if you can tell me that you did 2 steps right, 3 steps right, and I give you 0 credit, and you think you deserve 1 out of 3 points, you let me know. We'll talk about it. I'd love for you to take the time to go through your question, to look at the steps, and tell me exactly what you did right, how you could have done better.
I still got a B.
So what I had to see here was no solution, inconsistent, anything like that. Who's got a question on 5, 6, 7, or 8? 6. Okay, so what you're trying to do is have opposites. Well, these are in the wrong order. Oh, substitution. Your first step is to add 2y over here, plus 2y over here. And then you have x equals. And then you take that expression and you plug it in for x right next to the 5. Do it on a different paper. Okay. Oh no, right now if you were to not do corrections, I'd be taking points off. If you did not pass. Actually, I'd let you do anything. If you have below a 60 and you want to wait and do corrections after school, I'll give you some points back. So just wait. If you want to earn points back after school, just wait. What's that? Sure. Yes, definitely. As soon as you know a correction, put it up here in the front basket. Did you multiply the top by 2? 3. Okay, did you do -3? So if it was, because to add down you need opposite signs. So that's great. 3 is good. It just would have to be negative. Because it has to be opposite signs. You guys ready for the back?
No.
-6. Plus or minus y squared. 5 times 5 is 5.
Max, which one are you on?
No.
I'm gonna go on, and then you can. I'll go back to it. So every question's worth 3, including the extra credit. So here's the graphs I was looking for on the back. Actually, I could probably show you both of them.
Actually,
How do you?
I don't.
On the graph?
You have to do side show you start 5.
I did the 4 right. I think X for me.
So if you graph a line and shaded a line correctly, 1 out of 2, I should have given you half credit. So if you know that you got a slope and a shading correct on one of your 2 lines, let me know. You should have got half credit. Yeah.
So it has to be
Yeah, I understand.
-6 plus or minus
Well,
5.
you're doing it right here. This is where it's supposed to be. You see where it's right? You're supposed to shade this way.
I didn't see the slope of it.
I have no clue. I think it's or front.
I would have mind.
It's front.
What do you remember?
You shaded this in. You did this line completely right.
No, because we're completing the square.
So you got half
Yeah,
credit.
There's something that could
This one you got more based on
multiply to
Because that's not perfect square. That's not perfect square.
multiply to 1 and add to 4.
What do you do with the 4?
So it's not.
What do you do with the 4?
Try to create a scene.
Yeah, it's on the next section.
Alright, here's an example of extra credit. A consistent dependent solution is the same line. Those are the same lines presented differently.
Yes.
I am not available after school Tuesday or Thursday this week, so come Monday, Wednesday, Friday. I'm not available Tuesday or Thursday. I should just do that every week, guys. Just be not available Tuesday.